Hello again. We have Tony here. He's our replacement speaker, but he's going to give us an excellent presentation on the async nightmare. He's from Shibanik, and he hates swans because they're jerks, I guess. Thanks. Let's welcome Tony.
Hi, everyone. Morning, or hello, anyway. So my name is Tony. Thank you for joining me on this session. I know that most of you haven't read the title before hearing about it today, because these were printed before I knew I was going to present. So today's topic is the async nightmare. So this topic is for both developers and designers. Are there any backend developers around here? Yeah, you're kind of on safe ground here, because you're kind of just, talking about the front end, but something is gonna be fishy around there too. So without further ado, let's go do some demo. So this topic is going to be slightly demo heavy. I promise I will not riddle with code. If there is some code, it will only be just to showcase how big it is. So here's a demo that I have. It's a simple WPF application. It's called blocking, because the only feature it has, it's going to block. So the rest of the demos are going to be in JavaScript, I promise, but this one is to prove a point. So any of you doing desktop development, like desktop applications? Not Electron, like desktop development. OK, so just a couple of years. So let me go back 5 years into the past. My first talk ever, it was almost 5 years ago, was about async development. Basically, we tried to solve the following problem. This is a button that once clicked, you see the application is completely unresponsive. It's going to go like not responding, I don't do anything. And once it's done, you get a message that says it's finally done, and now you can actually use the window. But then we introduced this async paradigm. Let's make everything async so the code doesn't block our application, right? So this button will not block application, so you can see that application is responsive, right? And after a few moments, it's done. Like, this is just a toy example, proving a point. So you're going to say, well, most of you are going to say, like, I'm a JavaScript developer, I don't care about blocking the application, because in JavaScript, everything is asynchronous by default. Sure. So problem solved, right? Now we have code that doesn't block the UI. What I'm going to talk for 45 minutes, right? So I'm going to show you some additional demo here in the front end. It works. So don't ignore the designer or developer, not designer. So if I click here, after a while, something's going to happen. Yeah, it's a random list of first 4 numbers. If I click it again, it will give me the same list, so you don't see any results. So what's the problem here? Like, why am I talking about nightmare? Where is this nightmare? So is anybody going to say that this is a good UI or a good user experience? Am I going to say this is a bad user experience? Yeah, sure. So let's just go back to the slides for one small segment. So how do we do asynchronous stuff? When we are dealing with asynchrony, we're dealing with 2 different things. So one is the IO-bound stuff, like waiting for a network to finish something. And then once that is done, we're going to do something else, like display a success message, navigate to a different page, log in a user, whatever. Second thing that we can do is like process stuff, like upload files, download files, apply filtering, masking, the regular stuff that requires something to be done heavily on the background. Both things fall in the same category of waiting for stuff to happen. So how do we do that? So you have a simple, like, get me some stuff. Once you get a result, you do something with it. Once you get an error, you do something with it. So this is called like sending callbacks, and this brings you to callback hell. But I'm not going to talk about that. That's not the topic today. That's the topic for something completely else. The new shiny version of handling asynchrony is using promises. So you write the same thing, like get me some stuff, but then you use this chaining method of like once you're done, then do this, or catch errors and do this. And in the future, in ES7, we're going to get something beautiful like Async-await, where you can just like write await and you get stuff. So this is the technology part. This is how we solve asynchrony. So where's the problem? The main problem is that while the action is being done in the background, whether it's just waiting for the network to respond, or whether we're actually doing something heavy on the background thread, we have no idea if the action is done. So first problem is it done? Should we continue on? Second problem is, OK, so it's not done. So what's the current state of it like? How long until it is done? If errors happen, were there any errors? How do we handle errors? Results that come back from the background thread or the network response, how do we handle errors in the UI, right? And what about timeouts? Like, what if the network is gone? Like, you're driving through a tunnel and you lose connection, or you switch from Wi-Fi to the cellular and vice versa. What about ambient cancellations, where user goes away from the page and now the operation that was initiated needs to be completed? And also, can the user actually stop this operation? So these are all the problems that we have to solve, right? Another demo. This is going to be a theme today. So don't watch the slide miniatures there. It's going to spoil something. OK, so let's move on to the second demo. So if I click this button, it will not work as expected. I will click on this button. This won't work for a different reason. And even this button I will click, and nothing's going to happen. Can anybody guess why nothing happened? Does anyone want to try? I know I'm putting you in a spotlight. Could you give a hint? Like, what went wrong?
Server doesn't respond.
One option is that server doesn't respond. Any other options? Timeout. OK, and some more options. What? Yeah. So we don't actually know. Maybe I actually forgot to bind the click handler. Maybe I forgot about that. So without going into the code, writing debugger and putting breakpoints, we actually, even as developers, we have no idea what went wrong. It could be that we forgot to bind the event handler. It could be that the event is still pending. The results are back, but they're empty. If I'm going to display a list of results, maybe there is no list of results. Maybe there was an error. Should I show an error? Maybe it's still going. There are so many things that can go wrong, right? So let's make some progress. If I click here, oh, it's loading. And the text is wrong, but this really is random generated code. And notice something. So we wanted to show the user that the action is happening. So we just wrote like loading. And there we come to the nightmare part. Why? First, as a designer of a product, you have to think of these states, like, how do I display progress to the user? Then the developer has to go and implement that particular state. And then what else you have to do? For example, look at this button, fool me twice. So this is the same button as the previous one. It does the same action, but this button is disabled. Why? Because you want to prevent duplication of events. You don't want to go and submit the post twice. Like if you have a post button underneath the comment, you don't want to spam the post button and send 10 copies of the same comment, right? You want to just wait until the action is either failed or finished, and then re-enable the button so you can post another thing. So you actually, once you start thinking about it, you're introducing all these new concepts, right? OK, so let's move on to a more complete example. So here we're back at the square one. So here we have a fortune teller that will give us a list of results. It can give us a list of results. It can give us no results, or it can throw an error. So if I click here, I'm going to, OK, get the random list of results. Click again. It's random, so it's really random. No results, or it's still pending. I don't know. And maybe there, if I'm lucky, it's random. So eventually, I'm going to get an error. Get an error. It's a really basic algorithm. It's like if the random number between 0 and 100 is divisible by 5, then it's an error, because nobody likes 5s. Anyway, so I can't force it. So the final version that will work, and we designed this perfectly for the users, is going to disable the button, show the progress bar, and see, it wrote there was an error. So I know that there was an error. So the user knows that the action failed. And we can either re-enable the button so they can do the same stuff again, or we can actually disable, move them onto another page and say, like, stop doing that stuff. We also have a special text that says, like, there are no results. So this is a special thing. Why? Because think about it. If you're displaying a list of results and you're, for example, designing a search page, and no results are returned, you're literally displaying nothing because no results were returned. But the user doesn't know that, so you have to explicitly say, like, there are no results. So this is the complete version. Okay, let's go back to the slides for a moment. So what did we do? We moved. This is just for outline purposes. We move from a simple code here in React, where you have an intermixed UI and some little code and some little state, into this nightmare. we have to handle all of these side cases. And since only 10 minutes have passed, I'm just getting started. So what's the problem here? First, you have to account for all these states in your design. Then you have to design all those stages explicitly. Then you have to tell the developer, like, go implement all of these stages. And there is no there's no silver bullet. There is no like simple magic library that you're going to npm install and going to solve these problems. These are all complex problems that you have to introduce into your own product in order to make it better. I had a user testing session with my new product 2 weeks ago, and one of the first complaints were like, I clicked on this button and did it work? And actually it did work. The button did what it's supposed to do, but there was no confirmation message that the action was finished. And the other problem is if you have a destructive operation, you have to query the user like, are you sure you want to do that? Like, do you really want to delete this thing? So those are considerations that you have. Oh, I have this thing I don't have to click. So what do we have to do? Like, we have to first disable the button. Like, that's trivial, but you can forget that. Then we have to show progress, which has to be designed. And finally, we have to think about all these empty states. And this is the part for both developers and the UX designers, because you have to imagine all these states. And when this designing application, the application is not just a perfect UI with a perfect list of items with perfectly designed user avatars and everything. You have to accommodate for all those fail states. Typically, when I'm dealing with designers, I get like something like this. It's a beautiful design. It works great. And then I go implement it because the tables in database are empty because I'm working on a brand new product. When I query the results, there are none or just a few items that are being returned. The avatars are missing. The text is just, blah, blah, lorem ipsum, whatnot. So we can get caught up in this. We have to make a beautiful UI, but then we forget that there are all these different things in our application that can go wrong, and we have to accommodate for those. So this is another example. It's a login form. I'm going to show a demo of that too. So notice on the right-hand side, it's just login. Here's the username. Here's the password. Log me in. And that's the whole code that you have to deal with, right? And here is all in C#. Here is all the scaffolding code around it that has to accommodate for all those states and has to disable stuff, enable stuff, wait for the progress, and then display the results. So you can see the explosion of complexity. But if I take a look at the login button, which is really simple thing to write, because pretty much every application nowadays has a login form, right? So here's a simple login form. Notice that I have to provide validation. Like, if you cannot log in until you write a username, password. Now I can log in. Then we have to display progress bar, and once it's done, we're logged in. Right? Seems simple enough, but notice the explosion of complexity in both design and not this design. This is rather trivial. But notice the explosion in complexity. Let's move on to a different demo. It's called register demo. So here we have a simple register form. Again, sorry about the design. I'm a developer. What do we have here? Usernames are unique on the server. So we want to ensure that the username is unique. How do we do that? We check on the server, right? We can do this as a step in the register function itself, or we can preemptively test if the user can be registered. Oh, username is available. Finally, I can create a new account. Also, I have to write password, right? And if the username contains an A, because that's a forbidden letter, that username is taken and we cannot register. So this is a rather simple form, but this simple form, when compared to the logic itself, this is the actual logic. And this register function can go on the server and return an HTTP 400 and say bad request. The username is taken, or the email is invalid, or password is invalid. But this is all the UI. Is working? It's all the UI code I have to write as support for such scenario. And I haven't even started on writing. There is no XAML here, so there is no like front-facing code that you have to also write, design, and implement and test on your users. So this is all explosion of complexity. Now let's move on to progress bar. So when you're waiting, there are two different kinds of waiting. So one is waiting for a thing that might happen sometimes in the future. It will probably take a second, but still, you have to know that something's happening. And there's sometimes you know exactly how much time you have remaining. And those are two different scenarios which we handle two different ways. So again, a small demo. So here we have demo here. I'm kind of oscillating between desktop and front-end because I do both, and I think that both are showing exactly the same thing, just in different technologies. So you can see that this is not bound to JavaScript. This is not a problem that front-end developers face. This is a problem that developers face, right? So progress. You saw the indeterminate progress. You can see it again, and this is where you have knowledge of when the operation is going to complete. Think about file upload. When you have fixed size that you want to upload, you don't have to wait for it. And when it's done, you can start uploading again, or you can stop downloading. So you have different scenarios. Like you can either just display indeterminate progress bar, or you can show a determinate progress bar. This was an example of determinate progress bar. Okay, and this is something that you really have to design and implement in your application. Another thing is canceling. Like, so when you have operation that takes some time, the user might think like, I don't have enough time, I have to go, I don't want to wait for this thing to happen, and they want to cancel stuff. So how do you cancel stuff? You start something, and if you wait enough, it's probably going to finish. For example, if you're uploading a single image onto Facebook, it's going to be uploaded within a minute. But if you're trying to upload a 4 GB video, you know that at some point in time, you don't have enough time, you just have to leave. So we want to support cancellation. So this is an example of cancellation. But how does this work? How can we cancel stuff? So this is a tricky part. If we are dealing with a HTTP library like Axios or Bluebird, they support cancellation out of the box. But for regular promises that you make yourself, there is no cancellation support, so you have to build it yourself. If you're doing like C# development, you have cancellation built into the system itself. Okay. Another example is when we are thinking about progress bars. Like, we can just display indeterminate progress bar and we're done. But the new fad in the last couple of years are the so-called skeleton screens. This is the idea that you show something that resembles the future content that's going to be displayed, and once the content is displayed, it's going to roughly feel the same because this image is like faded out and just shows the skeleton of the screen. So if you want to do something like this, you have to design these screens explicitly. Also, if you want to be fully responsive, you have to design such screens for all screen sizes. So it's not simple enough. You don't have a library for this because these skeleton resemble your application. You have to do them manually. The reason I don't have a demo here for you is because I don't know how to do such screens. So I just found the example on the internet. But this is a new thing that you want to prepare your users and not just display indeterminate progress bar, because this is an example of indeterminate progress bar. You don't know when you're going to get the data. Maybe never. Maybe just lost the connection and you're not going to get the data, or you just got it. Okay. So about cancellation, how can you cancel stuff? Here's an example. This code will be available on GitHub. So as I said, there's no built-in support for cancellation. You have two different things. You have the source of cancellation. That's typically the UI, the cancel button, so-called. And then you wrap your underlying promise, which is a representation of synchronous task. And externally, from the cancel button, you say, OK, cancel it. And the internal promise can actually handle such thing, and it can know that once it's broken, it's going to fall into the cache handler, and it's going to cancel. This is just a small illustration of how the code will be expanded upon. And notice the explosion in complexity, because all the logic is typically here in this part. This is the logic that we are actually doing, and everything else is just a scaffolding to get this thing working in our system, right? So like I said earlier, if you want to do cancellation properly, some libraries support out of the box, but you have to implement it for yourself. The problem with this approach is, what if you initiate a post request to the server, and then you hit cancel? Can you actually cancel it? Does it work? Will the server know that you canceled? Like, which operations can be canceled? This is a problem that has to be solved on the back end, on the front end, and in design again. And there is, like I said, there's no silver bullet. So every time you want to offer such functionality in your application, you have to think about it yourself. And now I'm coming to the part which I really like, which I don't know how it's named, so I kind of named ambient cancellations. So the problem we are facing here is the following. When I showed you that blocking application, that old desktop application which blocks user input, so as a user, you click on the action, something's happening, the application is unresponsive. You're standing there, staring at the application, wondering if it's going to come back. Years ago, I had a really slow laptop with really slow hard drive, and I was downloading some files from the internet, and for a moment, for a minute or so, the whole computer was blocked. I couldn't do anything. The windows were paralyzed. When I regained control of the system, I went into the torrent client, and then there I saw that the torrent being downloaded at the highest possible speed, and that speed was faster than the hard drive, which was 4,020 RPMs. So the system was blocked, and I couldn't do anything. So this is a good user experience. Why? Because user is standing and waiting. But when we introduce the synchronous and all this pretty UI around it, now the user can do something else. The user can actually leave the current context. And this brings us to the problems. If you didn't guess it, it's demo time. So here I have a simple button. It's going to do something. What's it going to do? After a few seconds, it's going to show a message saying something's happened. It's done. Yeah, simple enough, right? So imagine if this is like order stuff form. You click do. I don't care. Close. So I'm back in some other part application. Oh, it's done. Damn it. So the operation was still ongoing. What about something more sinister? So we have do worse button. Do worse is nothing special. It will just open a new form. After a while, OK, so we got a new form. It's empty because it's a toy example. But if I click it again and I decide I don't want to wait for that, I'm going to close this window, I cannot close it. Why? Because I had to prevent myself from closing, because you cannot open a new window if you close the parent, it's going to crash the application. So how do you do that? You have to handle those corner cases yourself. I have an example in front-end. So front-end, you're not immune to this if you're in front-end, right? So if I click here and I leave, I will not leave because I want to show the point. So here we have alert. Yeah, hello. OK, so because this is a single-page application, and we are all doing single-page applications like React, Angular, whatnot, I will click on this, and then I'm going to move on some other demo because I'm not sure what I'm going to show next. So I'm going to see what other demos are. Oh, operation is done. Is this good UI? Nobody knows. Why? Because it depends on your application. Like, do you want to prevent your users from leaving the current context until the pending operation completes? Or do you want to have like a snack bar or toast message that says, oh, your upload has finished? So it depends on your application. There is no silver bullet for this. But you have to think about it. Can you let the user leave the current context? Because things might turn tragic. Because why? If you don't cancel stuff when the user leaves context, the follow-up operations might do something with the current UI, or they might initiate a chain reaction that will destroy the current context where you are. So this one is better, because this one will show a message once some time elapses, and will say, done. But unlike the other one, if I leave this page, I will never ever get that message. So how do I do that? I do so-called ambient cancellations. I'm going to move to the code here. I want to see what demo is this, demo 7. So you have two buttons. One is click and leave. One is better, obviously. So the click and leave button will just say, wait 5 seconds, then alert. The other one, notice that this is the handler for the first button, and this is the handler for the second button. Ouch, so much more complexity. Why? Because I have to remember that the operation has started. I have to cancel it once the user leaves. This is a lifecycle method that will fire once we leave the context. And we have to accommodate it. We cannot simply ignore such stuff. Because in the desktop demo, I opened the form. So you don't know what are the side effects of asynchronous operations. And if you don't manage them, they're not going to bite you in the ass. OK. So another demo, which is also nice, is race conditions. Who here likes race conditions? Yeah, some people like it. Good. You like to write them or like to fix them? So race conditions are not possible in asynchronous role. Well, sure they are. So here we have a simple master detail view. So this is a list of options. And once you click on option, imagine you're going on a server, fetching a JSON, then you're rendering that as a subtable or whatnot. It's a really simple demo. Like if you click on a button with a corresponding number, that number of seconds is going to pass, and then we're going to get details of this item, which says item is 1. If I click 3, 1, 2, 3, 3. OK, so I'm waiting for a certain number of seconds. What if I do this? Like I'm going to click 4, 3, 2, 1, 4, 3, 2, 5. Ouch. So because I initiated all those requests on every click, right? So all of these requests went to the server. And that doesn't make sense. We probably want that the last item that's going to be clicked to respond, because the synchronous requests over the network are going to complete in unknown order. For example, if I click 5, then click 1, because I'm simulating 5 seconds, I'm going to correctly switch to the first item, and then once the uncancelled request has finished, it's going to switch me back to the previous item, which I probably didn't want. We actually had this bug in our desktop application, and then we fixed it because it made no sense. When you're dealing with slow connections, these kind of errors become apparent. These are kind of non-existent when you have a really fast connection. And do you know when you have a really fast connection? When you're co-hosting your backend on your same machine. Then it works like immediately. But once you deploy it in production and you actually deploy it in Dublin, Azure, or Heroku in the West Coast, then the latency becomes an issue, and then you actually notice that things that worked fine in your desktop development environment suddenly don't work. So to fix this, what do we have to do? Here we have a better version. Here, only the last item will actually complete, in this case, too. So how do we do that? Again, notice the explosion in complexity. This is a demo 8, right? OK, so on is a handler for the first 5 buttons. It's quite trivial. Just does something. Ignore the details. Just compare the code size. And here is, again, the second one. And when paired with the lifecycle method, which I omitted here, the code will grow even more. Because what do we have to do? Every time we start a new operation, which is fetching the JSON from the server, we have to see, oh, am I fetching already? Should I stop? And if I need to stop, then I'm going to stop the previous operation. Is anybody using here reactive extensions for JavaScript? Anybody here? Just a couple of people. Reactive extensions have built-in method for selecting the latest sent event, so that this code kind of becomes smaller, but still it's a complexity that you have to handle yourself. So this was the demo. So how complicated can this thing get? Well, unfortunately, the answer is depends. It depends on your kind of application. It depends on what you're trying to build, right? Depends on how you're trying to present your user experience to your users. Just yesterday, I discussed a scenario where people initiate a really expensive operation on a backend, and there is a problem. Like if you click do, and it's being processed in the background. What if you restart the web server? What if you lose connection and then refresh the web page? Now the operation has already started on the server. Should I present the progress bar again on the front end? And how do I know that the operation is being done at all? Because we typically are used to request response nature of the internet. You send a request, you get a response, and you display the result. But if you have a long-running operation on the backend, then you have to bake that state into the backend. For example, if you are processing a 4 terabyte video on the backend, because that's like backend service in AWS, then you have to actually have somewhere, either Redis or database, you have to store that you are actually doing this operation, so that once you refresh the front end, you have to go back to the backend and ask the backend, like, am I doing anything on the backend? Like, this is like your extended hand, and then show the progress and possibly cancellation, because you can cancel such, for example, transcoding video on the backend. You can cancel that on the front end. So this is where the backend becomes important. For typical nature of like post-get requests, you don't need to do anything special on the backend. But when you have a long-running operations on the backend, like example transcoding video or similar, then actually the backend has to have the state that the front end actually just shows. But that's something you have to consider. Another considerations that I just want to get across is like when we are in the mobile-first world, as we are today. Even here in Croatia, we have really good internet connectivity, but around the world, that's not such a good thing, and people are losing connection all the time. How do we write UIs that are always up to date and show the exactly correct information that's happening on the back end? One fun thing is that there are applications that are doing optimistic updates. Anybody knows what optimistic update is? So basically, when, for example, if you have Facebook application and you have a like button, you click a like button, and UI actually pretends that everything went OK. So here we have Optimism. So we immediately assume, yeah, the operation went fine, but maybe we lost connectivity, maybe there were some validation errors, and then we realize, well, maybe we failed to do it, and then what do you do then? You roll back the UI. That's fine if you're still on the same page. Like if you're reading a post, you're liking it, it's liked, and then after a few seconds you get a message, there was a timeout, sorry, you couldn't like this message, or the message was deleted. So what do you do with your users then? What if they moved on? Like if they're scrolling through a list of things and they're ticking off actions like done, done, cancel, cancel, and one of these actions fails. How do you bring the user back to the context in which the action failed? What about the subsequent actions? Do you cancel those as well? Do you schedule them to rerun? How do you handle different kind of errors? Like there is error like you lost connectivity, there was a timeout, the server responded with an error. Those are not the same errors. In certain scenarios, you just lost connectivity. You refresh and you got new data. In certain scenarios, you had to retry the operation. How do you prevent the duplication of events on the background? So those are all the problems that you have to solve for yourself, for your application differently. And as I said, there is no silver bullet. And that all brings me to the final conclusion that although technological-wise, asynchronous code simplifies certain stuff, it surely complicates the user design, it complicates the design of applications, it complicates how we actually develop such applications, because we have to assume everything about the possible errors in the application, how do we present them, how do we handle them, how do we correct ourselves, and that actually is the hardest part, in my opinion, of developing a modern applications, is to handle all those corner cases, because there are also many corners on this development problem. So that's all I had for you today. I hope you found those demos illuminating. I will post demos on GitHub, and I'm going to tweet at the WCZG, so you can, if you want to see demos for yourself. And actually, the demos are hosted in Azure, so you can actually, click for yourself. So these are all the examples I want to show you today. Okay.
That was a great presentation, but also extremely depressing.
Oh, thanks. That's the compliment.
I was hoping you had the silver bullet at the end there for us, some library or something. Any questions from the audience? You guys are ready for lunch, huh? We still have one more presenter. One question here. Pass it down. Pass it down.
Yeah, so what happens if you create a source token and to use for canceling something? And for example, when you click cancel, you close the WebSocket and something. Can you push additional info to the backend to let the backend know that you canceled something? Can you use that, or do you have to write additional code extra to the cancellation token?
Additional code.
Additional code.
Yeah,
so
because cancellation as a topic in itself is really complicated. Not everything can be canceled. For example, pure HTTP requests cannot be canceled.
Yeah, of course.
Yeah, you cannot cancel those. But you can cancel the operations themselves. So if your operation is like instantaneous and you don't require like a double handshake, then sorry, it's gone.
Okay.
But if you have a process, for example, any long-running process like uploading stuff, downloading stuff, processing, applying, those things that take time, you can cancel those easily. But still, even then, you have to decide, are you canceling them on front end because you're preparing stuff for the upload, or are you canceling them on back end because they're being processed in, for example, a job, scheduled job, a cron job, whatnot. So additional code, that's always a solution to problems.
Should we stop using async requests?
Yes, you should block your web page whenever a person does something so that you prevent all of these problems.
Sounds simple.
Yeah, sounds actually rather simple, but it's kind of hard to block web page. You can display like a whole, blocking text and put in local storage. Like, you don't do anything, I'm doing stuff.
Any other questions? Yep. Can you pass this back?
Yeah, hi. Whose job is it to anticipate all these states of the application? Designer or the developer?
I'm a developer, so I'm going to say designer.
Yeah, but in the end, you do it, Like you said, you get always the one version, and then you have to figure out all the other states and.
I mean, as soon as you start developing any kind of solution, some things pop out when you start clicking. Right? We had an example where we got a specification in Word, and when then my designer turned that Word into like a workflow, and we found out that some things don't make sense, but which we didn't see in the Word part. And once we started clicking on it, when we started implementing, we noticed that there are additional problems. So every design medium hides some problems because of its nature, right? Static context never, that shiny image of beautiful UI doesn't show you what happens when you start clicking. And when you're a developer, you are actually developing more interactive, more, you can click on it, and then you realize that oh, nothing is happening. So is it my fault? Is it someone else's fault? How do I differentiate between those? And then you go back to your design and say, please design the disabled state for my button, because they design like perfect OK with perfect icon, and then you realize that we want to disable it, and what's the color of that disabled state? So those things, we have tunnel vision when you're doing stuff, and once you start experimenting stuff, you realize that you're missing something, and then you go back to your designer if they forgot to anticipate that, and then they will design it for you. But in my opinion, because designing web applications and applications in general is so ubiquitous, designers are expected to provide such designs upfront, because how else would you want to design application? You have to know about such things. Like there could be errors, there could be no results. You have to accommodate for those designs.
Hey, so I have one question. So I've been a web developer for quite some time, and so it seems like that this is something that isn't handled like generally very well in front end and back end. Like people do ad hoc solutions, like you mentioned on a case-to-case basis, but there's like well, at least now we have these like state management solutions like Redux and Flux, but everyone is doing their own thing. And so I get a bit scared whenever I'm like booking a flight or something, or paying with my credit card, and web page says like, please don't close the window now because it's processing in the background. So like, what do you think is the next step, towards the general solution for the web async process?
The problem is that even though this, for example, you have a form-based application, you have 10 different forms, you might say, I can apply the same logic to all 10 forms because you have the validation, you have the progress state, you have like that message, don't leave, please. And you can generalize from that, create some packages. And there are already some common middlewares for Redux, for example, where you can actually say that typically in this application we are used to do this way, so we can always have progress bar automatically somehow. You can do higher the components to actually hide this repetitive complexity behind framework-like code. The problem is that why the topic is named Nightmare, because there is no easy solution. The reason why so many applications do it differently because there is no standard, and there could be, in my opinion, there is no standard. It's not in principle possible unless we are agreeing to lowest common denominator, and we are creating standard components and say, okay, my standard form component will have built-in things inside it. But different scenarios require different handling. For example, you said data processing payments. That's handled differently from handling file upload, because how can you cancel a transaction between two background entities like PayPal and your credit card company and you? Like, where do you click stop? It's hard. That's the, in my opinion, the biggest problem. You don't actually know where to handle this. And that's why you have to handle it individually in each application ourselves. So, yeah.
We still have time for questions. All right. Well, thank you.
Okay. Thank you.